this computer. Is it recording? Can you see it? Like, can you see it blinking?
Yeah,
Okay.
I can see recording.
All right, cool. So we're back here. It was 10 gigs, right? Let's go back and actually do a df-h. Is this my Kubernetes df-h? BLKID or sorry, VG LV display. Right, it says 10 gigs, but we're not so sure if this is actually 10 gigs. So let's actually try to mount it. Did we already mount it? Did I mount it in the FS tab? What did I mount it as? df-h. I mounted it as kubevol. Okay, it's 9.8 gigs, you see? And it's already used this amount, so it's actually 9.3 that's available. But it says 9.8. So you should be mindful of that sort of thing. So this will be 9.8. You can't put something that's not there. 9.8. And file system, read-write ones, okay. Read-write ones just means that whenever a port claims this thing, another port cannot come claim it again, right? And recycle, storage class name, slow. Okay, I'll just take what default they gave me. These are options, like when you're using mount, these are just mount options. And usually I use something called REST vport. For my mount option, I use read-write as well. Read-write. But I've already used read-write once up here, so that's not necessary. Okay. The path that I want to mount, what's the path that we did? kubevol. You see, these are the information. Remember when we were doing the description, we talked about the name, all right? The path for that, it was 9.8. Remember we talked about that when we were explaining and drawing, using the drawing board. It was 9.8. The path is kubevol, right? So let's go look. Where is it mounted? It's mounted here, kubevol, right? So kubevol, and the server name, the server IP. Mm-hmm.
So on the, I have a question, please. On the,
yeah,
where you have storage, why not the dev mapper, the file system?
Is that a mount point?
That's the file system, right?
That's the file system. The mount point, we're sharing the volume over NFS, right? What are we sharing? Are we sharing the, when we put it in the Etsy exports, are we sharing the dev mapper, the volume itself, or are we sharing the mount point, right? So we're sharing the mount point over NFS. So that's what.
My problem is in here where you have storage. The storage you put by the capacity, right?
What does that mean? What does that mean?
That's what I'm asking. I'm seeing 9.8 gig.
All right, hold on. Let me do a df-h on there. df-h. Which one is it on? df-h here. What is this?
That's the size of that
yes.
mount point.
So what's the capacity? How much can you carry? What does capacity mean? The size capacity.
That's 9.8.
All right, so the next thing we do, we get the IP address. Did I already get the IP address? IPAS. So the IP address is, that's what's in the exports, right? So let's actually look at the exports. Let's show, let's show the exports first so that we confirm that we can actually see it. So show mount dash E from this server, right? So this is kubevol and it's coming from that server. So before we even put it in there, we have to verify first. So the server name, this server IP address is, insert this. So as simple as that, you already have your good looking, how do you call it? Persistent volume. That's all you need. You know, you just go to the thing and you get it from there. So now we have that one. Going to create the persistent volume claim, but I don't know, maybe we should actually create this thing first before we even get the persistent volume claims rolling. So first thing is, or one thing is create -f, kubectl create -f. I'm trying to go fast so that the video should not be so long when you're following, right? So kubectl create -f test pv, and it's created kubectl get pv test pv. All right, and it's read write once, is available. That's the name, the storage class name slow. So this storage class name, that is what points to, that's what we're going to use to point to this persistent volume. So we're going to use this name inside the persistent volume claim to point to this persistent volume called test PV. So now let's get our persistent volume claims rolling. We go back to the browser, write the documentation, and we go search for our PVC, persistent volume claims, persistent volume claim, right? So persistent volumes, where's claims? Volume. Where are the claims? Am I spelling it wrong or right? Persistent volume. It should be in there somewhere. Let's see. Command F. Claims. '94. Never gonna get to where it is. Okay, this is a persistent volume claim. This seems to be talking about using persistent volume claims. So we just go down. All right, here, volume claims, expanding it. This one's just expanding it. Nope, we want a brand new persistent volume claim. This is a persistent volume. All right, keep going. All right, here we go. There's a claim, persistent volume claims. Just copy this, copy that, and just go in VI, want to create test pvc dot YML, insert, paste that. All right, this last all of this stuff, this labels and stuff and selectors, you don't need. All right, just out of experience, you don't need that stuff. Except, you know, as a matter of fact, some of the stuff you see it in your environment, you just know what it means. But for you creating one that you want to be used, you don't need this for now. All right, so I'm just going to take all that part out. And you see the storage class name is pointing to slow. And that was for the persistent volume, right? This storage class inside persistent volume is also called slow. So this persistent volume claim knows where it's going to get the volume, to claim the volume. So here in persistent volume, this was 9.8. Was it? DF-H.
Yeah, it was 9.8.
Okay, 9.8. So we put 9.8 over there. All right. Name, we want to call it test PVC. PVC. All right, that's good. It's looking good to me. It's very short. There's not much. So let's try to create it. This is where things get messed up. All right, well, let's cross our fingers. kubectl create this thing. CL create -f. Test PVC. Create it. So let's verify if it actually did it. kubectl get PVC test PVC. Oh, right. And it's good. Looks like it's bounded. It's in status bounded. It's good. That means it's actually picked that stuff over the network. And now we have our persistent volume. We have a claim that has claimed it. And all we need is an application to grab that stuff, right? And we already have an application that we created before. Last week we created an application and it was using, but anyway, maybe we should just create one from scratch again and make sure it's using that mount point. Let's look at my volume here, volume 2. So if we remember, right, just creating stuff from last week, we created an empty there. So if you still have your empty there, all you have to do is just change the information below where the volume used to be, right? As you see here, I just changed the information. If you're doing the homework, you should have done this, right? So let's not do something that we're supposed to have done anyway. This here is the volume claim that we created last week as an example. It was actually lengthy and, you know, me and Michael were going on this for a while. The kind is part. So this is a part. We're creating web 1. The name, testing. This is a label, run web 1. And then the name is testing. The containers in there is pulling from my image, web. The name is, the name of this container is testing. The mount is var www.html. So here is where our volume claim is also going to be mounted. So we're going to call it HTML. So here, once you get this volume section, this is the only thing you need to change because before you used to have empty there. Let me show you from another file. Let me show you from volume, vi volume.yaml. Okay, so volume.yaml, this is what the volume section looks like. In your homeworks and stuff, when we were doing empty there, this is what yours look like. All right. Now I'm showing you what the new one should look like. Let's go back to the browser. Sorry. why I'm saying that all you need to change is just that tiny place. Let's go back to where we're using a part to claim the volumes, right? So as you can see, oh, this is still the claims. Where's the part that claims something? All right, this is a part that's claiming, right? And you can see for volume, this is it. It's no longer empty there, but that's all that changed. Remember? This is all that changes. You know, there's a name and there's a path. That's all right? Also, it could be using persistent volume claim. So let's go down. I think that one was a little different. Where's a persistent volume claims? Where's the pod? Just a second. Let's look for a persistent volume claim that actually claim from a persistent volume claim. All right, here, this is a good one. Claim as volumes, right? So this is a part that is actually claiming it, right? So this is what you need to change since you're using persistent volume claim. As you can see here, it's talking about persistent volume claim. So that's all you will need to do to copy and go replace the one that's inside your homework, right? So let me go into which one? I'll go into, which one should I even use? Since I already have one using empty there, I don't want to change that one. I want to change this one, but we already have it. So I'll just show you what I'll do. I'll just delete everything, right? Right, oh, and paste it. So you see, now the persistent volume claim, what you need to do here is change to your claim name. And what is your claim name? Let's go look. Your claim name is test PVC, right? Your claim name in this case is going to be test PVC. That's the name of the persistent volume claim. So, oh man. Test PVC. All right. So this is it. We're going to try and run it and see if we're going to have parts created. I mean, a part created with 2 containers using that volume. Now, cross fingers. kubectl.
Prof, the name of the volume doesn't matter.
What do you mean the name of the volume
Because in the
doesn't
file
matter?
just exited, the name of the volume was my port. That's what I'm asking, the name of the volume.
Oh. Yeah, thank you.
Yeah.
Yeah, that's a good question. I don't really think it really matters though, because here we're already specifying volume claim. It's not picking a volume. It doesn't know any volume, but because yeah, it should matter because we're using the volume here. Okay, so we'll use that HTML. Yeah, thanks. HTML, so that these parts here, they know the volume they're using is HTML volume. So thank you. I don't know if that would have really messed me up today because I'll start trying to figure it out. Like, where did I go wrong? You know? Anyway, so with that, we're creating volume 2. Okay, it says created, but let's see kubectl. get parts. 0 of 2 created. It's going to stay like that for a while. And then let's start describing and see what's going on, if it's even ever going to be created. So kubectl describe part testing, right? Oh, wow. It looks like it's created, right? And we can look at it from below. It says that successfully assigned, you know, it pulled the image, good. Created the containers, good. Everything looks like it's been created. Now let's look at the volume information and stuff like that. All right. Okay, it mounted, read write. It mounted the second one, read write. So the first container inside that pod is named test generator. The first one is called test. So everything looks good to me. I don't see like there's any problem. If there was a problem, it would have not even created those parts. So let's get those parts again and see. kubectl get parts, and you see 2 on 2 running. They're both running. So we've successfully created a volume, shared that volume over a network, successfully created a persistent volume to mount it on Kubernetes, persistent volume claim to claim those volumes whenever a pod needs it. We created a pod that needs those volume, and it accessed it through the persistent volume claim. So looking good to me. The next thing is to test it. Okay, so we know that the volume is mounted here in /vol. Okay, so in here /vol, first let's go here to the containers and try to write some stuff inside the containers first. So the way we access containers is kubectl exec, right? Exec dash it, the pod name testing, and then -c. We want to go into the first container is called testing. Is it? All right, container also called testing. How is that? It doesn't make sense. I don't think that makes sense. That's not it. So kubectl it, the pod name is, yeah, the pod is named testing, right? Pod is named testing. This one is called HTML generator. Volume, persistent volume claims. Give me a second. Test generator, okay? So why is this one called testing? It doesn't make sense. Okay, well, let's try it again. kubectl exec-it, the pod testing. You must specify a container -c. Let's try HTML generator first, since this thing is trying to mess with me. First one is HTML test generator. Copy. Oh man. Test generator. Yeah, guys, sometimes these things get messy for no reason, even as much as you try to keep it as clean as possible. error must specify at least one command. Oh, I guess that's why it failed the first time. I didn't use bash.
Yep.
Come on. What's going on? All right. Okay. What? All right. You laughing? Not funny. Is this var ww or is this var htdocs? I mean cd var ww. Okay. cd html ls. All right. Lost but found. That's very funny. So here I'm going to create something like make their something, whatever. I'll just so that you know that this is something coming from somewhere else. It refused. Say, okay, permission denied. Let's try sudo. Oh, why would permission be denied? This doesn't make any sense. Okay, that's because it's read only. I've mounted it on top of a read only file. Oh man, touch. Permission denied. Okay, read only file. That's why that volume is read only. Sudo touch this. Oh man. So it's not even going to create it. Why? Because that's a read only. So as a matter of fact, the only way I can do it probably is from the source where that volume is, and then come back in here and see if the stuff is going to be in there. So let's go where the source is. The source is right here. Let's see. ls. No. Where is this? df-h. Yeah, this is the source. cd. What is it? kubeflow. ls. You see, that's where the lost but found thing is. It's actually inside there. That's why it's. So if I create something from here, let's say make there. I hope it's not also read only from here. Make there Elvis. So I've made the dear Elvis here, and I should be able to see it in here too. You see, right? So it's actually claimed that volume, and it's done everything that's supposed to do. All right. So this is where the volume is created. This is if I do df-h on that cluster, this is where it created that volume. Kubevol. See? And it's sharing that over the network. Okay, so there's nothing fishy going on. If I keep creating stuff like that, I just made Elvis in here. If I do something else like touch, let's see, where am I? Remove dash rf, lost but found. And then I go back in my container, ls, it's not there anymore. Okay, so it's an external volume. It's actually an external volume. It's not connected to this to the Kubernetes parts in any way. If I delete the parts and I decide to create new parts and ask them to use that same volume, the same information is going to be there, right? The data inside the volume is not contingent to the parts existing, right? So the part does not have to exist for the data to be in the volume. So if those parts aren't existing, I can keep creating stuff inside the volume. But if the part exists, they benefit from that volume, right? They can just immediately start grabbing data from that volume. But if they're not there, the volume still stays. But it's different from when we did empty there, because once we deleted empty there, the ports also went away. I mean, the volume also went away because that volume itself is inside the pod, right? So now we created a volume that's not even that's not even part of the cluster, you know. It's just, you know, hypothetically, because this time around we use the cluster, but that volume could be on a different computer. It could be on a different network. As long as you can connect them over the network, that's good. The volume is going to be shared over the network, right? The data is being shared over the network. So that's what this whole exercise here did. So what do we do? What do we usually do? We create like a website on HTML, right? So right now, the only thing we can see is Elvis. If we want to have a website front page, we usually have, how do you call it? The index.html, right? We write something in the index.html. And in this case, where I'm creating that is where the volume is, not even where the containers themselves are, right? I don't need the container anymore. I just need to have that volume. All my changes, all the developers, they work and they're working and sending information to the data source, which is the volume. The hackers, they can come do whatever they want to do with those containers, break the containers down or whatever. They will not be able to get to the volume where the data is actually hidden, right? So it's a good thing, right? Because you don't link your data to the website itself where people can come hack it. So let's create an index.html on the volume, not inside the containers. So right now I'm on the volume. I'll create vi index.html. And in there, I'm going to add this and save it, right? Let's go back in here. I'm pretty sure if I curl localhost, it says Elvis, right? Why? Because index.html is now here, and index.html, you see var www.html, index.html is in here. And now cat, let's cat it instead of curly cat index.html. You got my name, right? So as a purpose of a persistent volume, okay? And now we're going to delete the part so you can see how powerful persistent volumes are. Okay, so I'm going to delete the part, delete all the containers in the part. So here we go. Let me exit out. Let me exit the part, and unless I'm inside my local host right now. So if I do kubectl, right? So you see I'm in my local host right now where I run the Kubernetes commands. Let it not be like I'm inside the pods themselves, faking it. No. So I want to delete the pods, all the pods that I created, even delete the volume claims and all of that stuff, right? I'll delete that. And then we're still going to go into the volume and see if the volume still contain the data. So first thing, pv, delete kubectl, delete the persistent volume. And what is our persistent volume name? Test persistent volume. All right. I want to also delete the PVC, test PVC, right? So that one is deleted. All right. I hope this thing deletes and I'll run it again. Probably because the containers themselves are busy using it. And nobody cares. You have to delete and go. Nobody wants you. Control C. So kubectl delete all. I'm gonna delete everything. All dash dash all. So it's deleting the part. It's deleting Kubernetes service. This usually takes more time. So I want to delete the part. So the part doesn't even exist, right? That's where I was in. I'm deleting that part, and we're going to just test the volume itself. Oh man, okay. That's deleted. Just to make sure nothing is hiding. kubectl get PV. It's not there anymore. Get PV itself. That was PVC. It's not there. Get parts. What's this part? Recycler. Okay, something is recycling. Delete. I don't want you to recycle anything. I want you to delete. kubectl delete all dash dash all. I don't want you to. Okay, services deleted. What's this recycle? Get parts. Oh, okay. Parts are gone too. All right. Now everything is gone. And let's go back to our volume, where our volume existed. All right. Let's ls. See, index.html is still in there. It didn't go anywhere. All right. So now I'm going to show you what I mean by the data is persistent, right? Because the volume is persistent, that means the data itself is persistent. So if I go create those parts again, once they arrive, they're going to have Elvis. They're going to have this index.html that has Elvis inside. Yeah, index.html. It has Elvis inside. Let's go create them one more time. And that's the class. All right. That's going to be it for today's class. We've actually covered a lot. So kubectl create. What are we trying to create? -f PV first. pv.yaml. Create it. The next one we want to create is PVC. Oh, sorry, not PV. Oh man, it was test PV. Sorry. kubectl delete PV. So it's deleted it. Now let's create it back. Test pv.yaml. Okay, it's creating test pv.yaml. Then test pvc.yaml. It's creating that one. Then we're going to create the part which was volume, right? Volume 2. All right. So it's called testing. That's the name of it, testing. That's fine. So let's kubectl get parts. 0 of 2 creating, so it's still doing its thing. Let's first get this PVC and see if that didn't fail. Okay, that worked. Still creating. Oh, now it created everything. Okay, what we want to do is exec into one of those containers again. So it's kubectl exec -it testing -c testing bash. Okay, so now let's curl it. Curl localhost. And you see that data just magically appeared in brand new containers. right? Elvis just magically appeared. Well, like I said, it's not going to go away. It's going to be there. As a matter of fact, let's go into index.html and see if we're going to see this same stuff. So cd var www index.html. Sorry, var www var h. What is it again? www html. Sorry. ls, and you see the same data came inside the container. I didn't create that container having that data. It just magically appeared on it. Why? Because the volume claimed it, right? Right? So you see volumes for HTML. That's the volume name, right? HTML. And they all claimed it. See? HTML, var htdoc. What's the other one? var www.html, right? From here. The container with the mount path var www.html is claiming from HTML, which is the name of the volume. Where's the volume? Right here, called HTML. Okay. So that's it for the class today. You know, the rest is just going to be questions and questions and questions. Okay. Let's actually go into this one and see what's in there. This HTML generator. Curl, if it accepts that sort of thing, localhost. I don't think it has curl installed. Yeah, it doesn't have curl installed apt yet. Elvis, you know, and this one exists where in var htdocs. See, Elvis index.html. Both containers have the exact same stuff that's inside the volume. You know, this is a second container, so everything is verified. You know, so more questions, you can just watch this video completely. All right. So now I'm going to just answer questions and stuff, because I try to make the video like not too, because the videos are usually very long. This class was going to be too long, so I made it very quick so that you can just be watching the video and understand. I'll send you the homework soon. So stop sharing. Stop share. And guys, I need questions now.